Today we're looking at notes V-3, trig proofs, day 3. So on number 1, we want to prove secant of A over sine of A minus sine of A over cosine of A equals cotangent of A. So the biggest thing on this problem, first off, is that you cannot simplify, meaning like simplify this sign with this sign, or slide until the problem is all multiply or divide. So not allowed to simplify with this minus in between, okay? So the first thing we need to do then is get an LCD. Look at that least common denominator. Find out what that would be. That way you can actually subtract these two fractions. So you see now why we practice that stuff from Algebra 2. So we're going to multiply this side by cosine of A over cosine of A, and this side by sine of A over sine of A, because of course that would give us the common denominator of cosine A, sine A. So the top is going to be secant A cosine A over, we'll make the bottom be cosine A sine A minus sine squared A, right, times, over cosine A sine of A. Okay, so now we have a common denominator. So, of course, when we have that common denominator, we can actually combine. So, secant A cosine A minus sine squared A all over that common denominator of cosine A sine of A. So first we did the LCD, then we have here that this secant of A cosine of A is a reciprocal pair. So reciprocal pair. So this is 1 minus sine squared of A over cosine of A sine of A. So like I said, secant of A and cosine of A, that's a reciprocal pair, so that makes 1. Okay, and then this, of course, hard to kind of circle here. This is a Pythagorean property. Pythagorean property that 1 minus sine squared of A will turn into cosine squared of A over cosine of A sine of A. And this all should be dragging down equals cotangent of A equals cotangent of A equals cotangent of A. You know me, I get excited. Equals cotangent of A. Okay, now we can actually simplify. We can simplify because now the whole problem is multiply slash divide. So now I can say, okay, well, one of these cosines up top simplifies with one of the cosines on bottom. So then I'm just left with cosine, a single cosine of A on top over sine of A. And what do you know? Cotangent of A. So I used the Pythagorean property, and then I was actually able to simplify because finally we had just a fraction, not two fractions. So a single fraction meant we could simplify this cosine with this cosine, and then I'm able to use my quotient property, that cosine of A over sine of A is the same thing as cotangent of A. All right, so these were our steps, and that's our final result. Okay, so I think I'm going to need another sheet of paper for number 2. So on number 2, we have tangent of A plus cosecant of A cosine of A should equal cosecant of A secant of A. So first thing we need to think about is, let me get my purple pen. we have to use basics to simplify each half of plus sign before deciding on LCD. So of course, just like before, we cannot simplify before this is all multiply or divide. So tangent will turn into, unlike before on number 1 where we could easily see what the common denominator would be, here we need to first turn into tangent into its basics, and same here. So tangent is sine of A over cosine of A, plus cosecant is going to be 1 over sine of A, and cosine is going to stay cosine of A, and that's got to drag over to cosecant of A, secant of A. So I'm going to, of course, put these as they should, sine of A over cosine of A, plus this is cosine of A over sine of A. So I know that kind of goes against the slide thing, but we're just sliding on this one part that's only multiply or divide. So equals cosecant of A, secant of A. So now it's pretty clear to see that I need to multiply this by sine of A over sine of A to get that LCD, and this by cosine of A over cosine of A. So again, that first step here is we used our basics. Okay, now we can find the LCD. All right, so we used our basics, now we find the LCD, and we have. So then we're going to have sine squared A over cosine A sine A plus cosine squared A, oh, I can already see where this is going, over cosine A sine A equals cosecant A secant A. So now we've got our LCD and we can combine. So add across the top. In this case, it's not subtract, it's add or subtract across the top, and in this case, it's add. Keep the bottom the same. Cosine of A, sine of A, just like you do with any other fraction. Add or subtract across the top, keep the bottom the same. Okay, so kept the right the same there. And then, of course, like I said before, you can see where that's going. That's your Pythagorean property. So this is 1 over cosine of A sine of A equals cosecant A secant A. And you can now probably very clearly see. So we did LCD, we actually combined, we used our Pythagorean property right here. Pythagorean property, and now we're going to expand and say this is the same as, right? So after our Pythagorean property, we expanded this back out because now we're going to use our reciprocal properties in that this is secant of A and this is times cosecant of A. So this whole thing here is that. This whole thing here using our reciprocal property is that. Cosecant of A, secant of A. Not that it's a huge deal, but these are backwards, so we're just going to switch it. Cosecant A, secant A equals cosecant A secant A. Okay, so done and done. All right, so number three. Number three. Over 1 minus cosine of x plus 1 over 1 plus cosine of x should equal 2 cosecant squared of x. So again, you want to get that LCD. So LCD first. Use this space out here. LCD. Right. Okay, so LCD first. So you're going to multiply this by 1 plus cosine of x, this by 1 plus cosine of x, this by 1 minus cosine of x, this by 1 minus cosine of x. Okay, you should notice that this is like backwards difference of squares, hopefully. So this would be on top here when that distributes, of course it's only 1, so 1 plus cosine of x over 1 minus cosine squared of x plus 1 minus cosine of x over 1 minus cosine squared of x. So now you've got that common denominator, so this would be combining like terms. This would be 1 plus 1, which is 2. The cosine of x's are going to cancel each other out. So 2 over 1 minus cosine squared of x. So finally, we should be dragging this down to cosecant squared of x should equal 2 cosecant squared of x. This right here is Pythagorean property. Okay, Pythagorean property. So then you have 2 over sine squared of x, this Pythagorean property, equals 2 cosecant squared of x. All right. So then, of course, you're going to expand because you've got this sine squared. So expand. Expand. So you would have 2 times 1 over sine of x times 1 over sine of x should equal 2 cosecant squared of x. And it does because, of course, this and this, using your reciprocal property, is 2 times cosecant of x times cosecant of x equals 2 cosecant of x squared. Excuse me, cosecant squared of x. So then 2 cosecant squared of x equals 2 cosecant squared of x. Yay! Okay, number 4. Tangent to the fourth of x should equal tangent squared of x, secant squared of x, minus tangent squared of x. Ooh, that's ugly, isn't it? Okay, so tangent to the fourth of x. Of course, you can expand that to be tangent squared of x times tangent squared of x. And then, because of the way this looks, right, there's this minus in between here. I'm thinking, oh, that's going to use one of our properties. So let's try. We have tangent squared in front. We know we want to keep this tangent squared in front, so let's do that. Tangent squared x in front. Replace this with your Pythagorean property, and this becomes, right here, this becomes from the property secant squared x minus 1. Well, if you FOIL, or distribute, excuse me, not FOIL, but distribute, this would become tangent squared x secant squared x minus tangent squared x, which is exactly what we want. So of course this was supposed to come down. Do that. Okay, so we're done there. So then let's try one more. So sine cubed of x cosine to the fourth of x equals cosine to the fourth of x minus cosine to the sixth of x, that quantity times sine of x. So you know a couple of things. You know that you want the sine of x outside here. And so we're going to break this up in a funny way. We're going to do sine squared of x cosine to the fourth of x sine of x. That's because, look at this, we know we want that sine on the outside. So we're going to expand kind of in a funny way to try and manipulate it to look like that. You do know from your Pythagorean property that you can change this. So let's try that. You can change this to be 1 minus cosine squared of x times cosine to the fourth of x sine of x. So if you distribute this into both of these, you would have cosine to the fourth of x sine of x minus, that'd be cosine to the sixth of x sine of x. And then, of course, you can factor out the GCF in the backwards kind of way, and this would be cosine to the fourth of x minus cosine to the sixth of x. Factor out that GCF of sine x from both. So Pythagorean property, then we distributed, and then we went back to do the GCF. So all of this equals, along the way, cosine to the fourth of x minus cosine to the sixth of x, that quantity times sine of x.